Everyone's talking about agents these days, but I have a suspicion that a lot of people are talking about them, but not actually doing them. In our case, we're going to have a project manager, where this is a project called Genesis. We're going to have a Genesis project manager, and we're going to have a Genesis worker. And those people, those workers, or those agents are actually going to be able to reach out through an MCP server to manipulate a Kanban board, create a Kanban board, plan out these different tasks that are required to create a model from scratch. And we're going to see all of that get populated here in just a minute through a simple web form that we fill out. And we'll have these agents that will eventually appear here, and we can chat with them and interact with them if we need to step in when they're doing their work. And I'll show how all of that functions. But right now, everything is empty. We're filling out the identity. That could be like the sol.md, but we're not going to create those flat files directly. We're going to fill out the identity through this form. And we're going to give it a name, give it a directive, description. So role and personality will come next. What's your role? What are your capabilities? And when we get here, this is a custom developer hub plugin that I created. And it allows us to attach knowledge bases, skills, and tools. Those tools are those MCP servers, so that I want it to be able to go in and create a Kanban board, manipulate issues, move tasks, stuff like that. But it's also going to have these different skills. It's going to select these agent platform capabilities. So knowledge bases are context that you want it to have. And these newer models are much better at traversing a directory structure and flat files. And rather than having anything sophisticated, like, maybe if you've heard the word retrieval augmented generation, we don't necessarily have to do that to give our agents some extra context. So between skills, our MCP tools, and our knowledge bases, our agents are going to be pretty capable, especially since they're going to be running inside OpenShift and have all of these extra abilities. So what we did here is we were successfully able to generate that project manager. Now, what does that mean? I'm going to go ahead and click my open in catalog. This is eventually going to populate. So right now we've got our knowledge base, we've got our skills, we've got our tools. So this is the same plugin that we created before, and it's just a different view now that it's in our component. Well, let's take a look at view source. This source we have in our cluster here. We have something called OpenShift GitOps. If I do a search for Genesis, we have our project manager agent. It's been turned into an application set, and that application set is syncing this project or this Git repository on the fly through our template. And there is an operator that is managing all of that. So if we come back here and look at OpenShift, and we were to take a look at our ecosystem, go to our software catalog. So there's an operator that I created called Agent Office, and it's installed, and it is managed by OpenShift and uses the OpenShift Operator Lifecycle Manager. And it knows and understands these new custom resource types. So if we come back here, we've got our agent workstation, we have our agent gateway. So all OpenClaw agents have a gateway. You can attach multiple agents to a single gateway if you want, but right now we're doing kind of a one-to-one. But these knowledge bases are also now a native Kubernetes type. And we have this customization, which allows us to create a bunch of these with different variables and different values. And all of that then gets synced by OpenShift GitOps, which is supported and managed by our OpenShift cluster. All right, now we have to do the same thing for creating our project, our Genesis worker. I'm going to do something similar where I have Playwright drive the user interface for us. It's going to fill out the identity. This is the one that's going to do the work. So the next page will fill out its role and personality. It's a worker. You'll notice that this gets checked now. We're going to create a new knowledge base, and it's going to accumulate knowledge over time about the work that it's doing. And then we could attach that. So that's going to get saved off in a Git repository. Later on, it gets attached as a persistent volume claim to other agents that you choose. And then it will be able to take advantage of the knowledge that these agents or this agent is learning. And so all of these agents can get smarter over time. So again, we're going to let the scaffolder do its job. and we should see all the green check marks go, and that means our component will be complete. And then we can take a look at our current state. And our current state, one of the things I want to show is we should expect to see, right? So we have a Genesis PM now. It was just refreshed and created brand new because this is archived information. And we're going to be able to talk to it. We can say things like hello, and then it will, Genesis PM is typing, uses WebSockets to communicate. We're going to hold off a minute until we get our Genesis. So right now what's happening in our applications, so if we do Genesis, eventually we should see another application pop up here with, right, there it is. So if we take, again, look at our Genesis application, right, it's going to sync the agent workstation, agent gateway, and knowledge base, as well as, some other things that it needs. All right. So from there, let's, everything is synced. We should be able to see if we hit reload up here, we've got our Genesis worker now, so we can communicate with both of them. So one of the things that I want to show is, and emphasize, is how, a lot of times people gloss over, how do these agents, how are they able to do things that require authentication? And here's where the platform comes into play again. I don't want to have to do what a lot of people do, is they just give their agent. So when they're talking, you've probably done this. You're talking to your agent, you wanted to access something, and you say, well, here's my token, here's my credentials, and then who knows what it could potentially do with those credentials later on. My agents never actually see the credentials. So we have this agent runtime. It authenticates as itself. So there's a GitHub bot, and it has a short-lived app token that gets generated every 30 minutes. But we use Red Hat Connectivity Link that has these different CRDs, so MCP server registration, that is going to do the work. So every time that agent needs to call out to GitHub and take advantage of its API for generating projects and issues and things like that, it's going to immediately get intercepted by this connectivity link gateway and the MCP server registration, and force the route through these channels. And those channels get the secret via HashiCorp. So the secrets that are getting rotated every 30 minutes by this functionality. So we have an external secrets operator that is getting the GitHub access token refreshed every 30 minutes. It puts that into the HashiCorp vault, but also then will update the Kubernetes secret with that value. And then that is what will get injected through this connectivity link mechanism, rather than the secret being stored directly with the agent long term. And it can do potentially something that when you're sleeping, you don't want it to do. In this way, it never sees the token. It just goes through these guardrails, and it's a much more production-ready way of doing things and being able to talk to these types of skills. All right, so now that we called that out, the next thing that we're going to do is get some real work moving. We're going to give our project manager a prompt. You are the project manager agent for the Genesis model project. Build the smallest, most concrete first principles predictive model trained on OpenShift AI. You could pause the video here and read the rest of what we're going to do, but it will be apparent in a minute here. All right, so once I gave that prompt, eventually, right, the project manager has its skills, has its abilities, has its tool to be able to go out and create the project in GitHub. So let's look at that. So let's go to our projects. Right now we still just have 2. Let's reload that. And eventually we will see another project. All right, so the project is there now. We're going to click it. There aren't any backlog items yet, but eventually those backlog items will appear. So let's give it another second or 2, and then the project manager will be using that MCP tool. First, it used the tool to create the board. Now it's actually using the tool to create the actual work plan for the worker. So the worker is not going to just pick those up yet. We're going to have to prompt it to do that. So we're going to go to our worker now, and we're going to tell it to actually pick the first one and try to get that done. Let me go back and talk to our Genesis worker. All right. So eventually, find the lowest numbered open issue on the Genesis model board and complete it end to end. Consult your first principles knowledge base. And then the next prompt is where we tell it to use the skill for data science pipelines. And I can, I've mentioned that a couple of times, but when I go in, so if I were to take a look at my OpenShift AI and I look at, so there's a lot in here. We have Gen AI Studio, develop and train. So if we were to come in here and look at our catalog of models, we could just spin those up, our registry. So these are where you could do something like auto ML or auto research. And then once it's done, or anything, this model that we're training, at the end, we can put it into our registry, and then we could serve that with something like VLLM. All right. But what we're going to look at is our pipelines. So if we look at our experiments right now, we don't have any experiments for our Genesis training that the Genesis worker is supposed to be doing. And that's what we're going to tell it to do next after it has completed its first task. So if you can see, the worker went ahead and completed implement a one-layer model from this. So let's take a look at what this is. Write the simplest predictive model, such as a single linear unit with explicit parameters and a readable forward pass equation. This information about what the model should be is actually embedded inside the skill. So if we were to go back, for example, and look at our developer hub, right? So if we come back to self-service, go to catalog, let's take a look at our Genesis worker, and let's take a look at the skills. So again, these skills are actually being stored in Quay. So if we were to take a look at Quay, for example, I'm storing the skills in this office, agent office skills. So some skills have scripts, and in this case, we have a script. One of those scripts is the actual, basically the model code. And when the agent gets created, right? So if we were to take a look at this and look at our skills catalog, we have the train the Genesis model skill that I wrote. I wrote it, and then I uploaded it as an OCI compliant image with the script and the MD file that it's going to be able to use to know how to use OpenShift AI data science pipelines. So it has tags, it's got tag history, right? And I used Conflux to build this. So Conflux is the Red Hat way of building software. So this image gets packaged up, stored into the repository that is running also on OpenShift. So it's the enterprise level OpenShift repository. And when the agent gets created, pulls that image down, puts it, mounts it into, and gives it to the agent. The agent isn't going to put all of those skills at once into its context. It's going to be able to discover those by traversing the directory structure of its skills. So I just wanted to mention that. I think it's worth talking about. Then when we come in here and say, train the Genesis model on OpenShift AI, now using your Genesis train skill, run the skill, wait for its result line, and report whether it learned, recovered, W approximate 2, B equals 2, and then the run name. All right. So we should be able to eventually come in here, look at our experiments, and there should be a new experiment around this Genesis model that gets started. And then once that happens, we should also be able to go in and see the Kanban board. So the worker also has the MCP registry tool for GitHub, and it can come in and take so if we look over here, train the model on OpenShift AI and record the result, you'll see it just moved over to in progress. And if we were to take a look at we should be able to refresh this now. And because it's in progress, okay, it's in progress, but it means that it's about to start the experiment up. We shouldn't have to refresh the page. It'll just appear. Come on, there it is. All right, here it is. So Genesis model. And so this is going to be the data science pipelines that are part of OpenShift AI. And you get a nice visual. If you click down through the hyperlinks, we'll be able to see what the steps are of training this model. So right now it's on this train-GD. And then we'll do an evaluation. So MLflow is, you can think of data science pipelines as the doing part, and then MLflow as the recording part. But MLflow gives us this nice user interface that once the experiment is done, we'll come in here and take a look at our different graphs to tell us whether or not the training was successful. All right, let's take a look at our board to see where we're at. So it's still in the process of training. We're going to look at our OpenShift AI. So if we look at experiments, it's not yet done. It's still running. It completed. We should be able to see if we go back into our backlog. This should get moved over to done automatically by the worker. We shouldn't have to tell it to do that. We already did. Okay, let's talk to it. Did you complete the work and move the in progress task to done? It's going to talk to us now. Ah, yeah, we convinced it. So it moved it to done now. And let's take a look. Well, I'm kind of curious what it says back. Yep, it finished. Learned, yes. Run name. Okay, we just had to coax it a little bit. That's the human in the loop. All right, well, that's probably better than everything going perfectly smooth. It normally does go perfectly smooth, but sometimes it doesn't, and it's helpful to be able to chat with our agents and kind of nudge them along. All right, and let's take a look at our MLflow. If we go into experiments, go to the Genesis model, and we click on the latest one, so 6 minutes ago, and look at the model metrics. Especially if you're a data scientist, this will be useful to you, right? One of the things that we had set is that in order to be successful, we can't have loss that's above 0.24. And in this case, right, we can see that we've met our requirements for a successful training. And then our model, we could put into our registry, serve it, use it in some sort of other workflow, but we'll leave it there for now. And I think this was pretty awesome, right? We've got 2 agents working together through this Kanban board, this project in GitHub, without access to the tokens directly. It's able to authenticate and use all of the capabilities of OpenShift, data science pipelines, MLflow, and this connectivity link to make all of this work just happen. Now we don't necessarily have to rely so much on that low-level data science knowledge. We can lean on our agents when they have tools in a platform like this that have data science tools. Your agents can be those data scientists that dig in deep, and then they can explain how they did the work later. I could have a conversation with my agent, and it could tell me, yeah, hey, we trained this model. This is what the actual code of the model was. And if you don't know what it means, ask the agent what it means. So I think it's all really powerful. With that, thank you very much. Hope you enjoyed the demo. Thank you.